Alrighty, I have no idea what happened. I think my just lost internet and then it got back in. The only other thing that I was going to note here is our polynomial inequalities. So this is 6.1 continued, by the way. Um, when we're solving these, just like regular factoring or different ways to do this, um, when it comes to polynomial inequalities, it's always in these type of forms where it's like less than zero, less than or equal to zero, greater than zero, or greater than or equal to zero. When you solve for x with inequalities, those are our boundary numbers, and we have to choose test numbers between those zeros to figure out what the graph is doing. Is it above the x-axis or below the x-axis? So if we're looking for less than, we're looking for negative numbers. If we're looking for greater than, we're looking for um, positive numbers. And then if it has a line underneath it, it's a bar. If it has no line, it's a parenthesis. So things like that. So this would be, brackets, parentheses, things like that. All right, so that's the only other thing. So let's just kind of jump into some exercises. We'll be on page 384 today, and I'm going to look at number 17. So 17 says 6x to the 7th minus 3x to the 5th equals 3x to the 4th minus 6x squared. And we're just trying to determine is x equals -1 a true answer for it. So again, the thing says verify the given values of x, solve the corresponding polynomial functions. So it starts off with just kind of like evaluation problems. So anywhere there's an x, we're going to plug in what x equals. So this would be 6 and then -1 to the 7th minus 3 times -1 to the 5th equals 3 times -1 to the 4th minus 6 times -1 squared. So in this case, anything with a negative and it's raised to an odd exponent, it'll stay negative. So this becomes -6. Again, this will stay negative. So this will become +3 because a -3 and a -1 become +3. When it's an even number, it'll go positive. So 3 times 1 would just be 3. And then again, this will be positive. So -6 times 1 would be -6. So -6 plus 3 ends up being -3, and 3 minus 6 is -3. So this would be a yes. And that's all you're doing is verifying, is this a solution, yes or no? All right, and so the next type of problems you'll see are like number 24, which is x cubed minus x squared minus 6x equals 0. We're going to solve the following polynomial equations by factoring and or using the quadratic formula, making sure to identify all the solutions. So the only techniques you know right now, you're going to learn some more in 6.2. But all you know right now is factoring in the quadratic formula. So I'm going to factor out a greatest common factor, which in this case is an x. So x cubed divided by x is x squared. X squared divided by x is just x. And then -6x divided by x is -6. So then from there, we can do the t-chart. What multiplies to -6 and what adds to -1. I'm going to open a double set of parentheses. Leading term is an x. Two things that multiply -6 but add up to 1 is -3 and +2. So -3 plus 2. Remember, the order doesn't matter. Then we're just going to set all of these equal to 0. So x equals 0, x minus 3 equals 0, and x plus 2 equals 0. This one's solved. This one I just need to add 3. I get x equals 3. This is -2, so I get x equals -2. I believe the way they want you to write the answer is just least to greatest. So you would write x equals the set of -2, 0, 3. I don't know if they'll count off if you don't put it in least to greatest, but all the answers I saw were least to greatest. And so that's basically what you do. Greatest common factor, then try to factor. If you can't factor, you just use the quadratic formula if need be. The next question is number 38. So this is the different type of questions that you'll see. And it says for each of the following polynomials to determine the degree and the leading coefficient, and then determine the end behavior as the graph goes to positive and negative infinity. Right? So I get r of x equals 3x plus 5 times x minus 2 times 2x minus 1 and 4x minus 7. First thing you want to do is identify all of the leading terms of each of those polynomials. So 3x is a higher degree than just a constant, x, 2x, and 4x. Those are all the leading terms of each one of those polynomials. So when you're looking for the ultimate leading term, instead of multiplying all of these out, just multiply these four things. So 3x times x gives me 3x squared. 3x times 2x gives me 6x cubed. And then 6x cubed times 4 gives me 24x to the fourth. So 24x to the fourth will be your leading term. And since that's the only thing it's asking, there you go. Then from there, just ask what is the leading coefficient. So the leading coefficient would just be 24. And the leading degree would just be 4, which is the highest exponent. And then from there, it's asking you to describe the end behavior. So since I know it's a positive even, then I know the graph is going to look like this. Right? So if it's even, it's either both up or both down. So since it's positive, then they're both up. So the way it wants you to write this is as x goes to negative infinity, f of x would go to positive infinity. As x goes to positive infinity, f of x will still go to positive infinity. And so those are all the answers you're looking for. All right, let's do another one. Let's look at number 41. F of x equals negative 2 times x plus 4 times x minus 4 times x squared. Oh, I guess it is in parentheses. So again, just circle all of the leading terms of each one. Negative 2 is the leading term of its polynomial. X, x, and then x squared. So negative 2 times x is just negative 2x. Negative 2x times x is negative 2x squared. And negative 2x squared times x squared gives you negative 2x to the fourth. So our leading term is negative 2x to the fourth. The leading coefficient is negative 2. And the degree is 4. So again, this is now a negative even. So that means my function will now do this. So then I go, all right, well, then that will tell me that as x approaches negative infinity, f of x will approach negative infinity. And as x approaches positive infinity, f of x will approach positive infinity. All right. So the next type of questions you'll see is 43. And on this one, for each of the following polynomial functions, determine the behavior of its graph and identify any x and y intercepts, and then use that to sketch the graph of each polynomial. So you have g of x equals 3 minus x times x plus 2 times x plus 4. So again, I need to do the leading term first. So in this case, negative x is the leading term of this polynomial, because again, it's bigger than a coefficient, and then x and x. So that right there will just give me negative x cubed. So my leading term is negative x cubed. The leading coefficient it would be negative 1, and the leading degree would just be 3. So a negative odd does this right here. So think of a cubic, and if it's negative, flip it. That's the way I remember it. So therefore, then my end behavior as x goes to negative infinity, f of x would go up to positive infinity. As x goes towards positive infinity, f of x would go towards negative infinity. And then it says it wants us to determine x and y intercepts. Well, x intercepts, we would set all of these equal to 0. So 3 minus x equals 0, x plus 2 equals 0, and x plus 4 equals 0. So this would be subtract 3. So you get negative x equals negative 3. And if negative x equals negative 3, then positive x equals positive 3. Then subtract 2. So x equals negative 2. Then subtract 4. And you get x equals negative 4. So there's your 3 x-intercepts. And then to find your y-intercepts, we just got to plug a 0 into x. So this would be 3 minus 0, 0 plus 2, 0 plus 4. So this is 3 times 2 times 4. So that's 8 times 3, which is 24, or 6 times 4. So the y-intercept is 24. So when trying to graph that, I'm going to start off with my x-intercepts. So I got 1, 2, 3, one right there. I got 1, 2, got one right there. 3, 4, I got one right there. Knowing that the behavior is here and the behavior is here, I can kind of guess it's going to probably do something like this. And since it's positive 24, probably way up there, and then it'll come back down right there. And so we'll say that that's 24. I'm not going to write 24 ticks. But I think on your homework, you just kind of plug in the points and then it gives you the dots. All right, let's do another one of those. Let's look at number 47. So we get s of x equals x cubed plus 3x squared plus 2x. All right, so on this one, I'm going to try to, I'm going to answer the rest of the question. So the leading term is already done for me. It's simply x cubed. The leading coefficient is 1, and the leading degree is 3. So again, this is a positive odd, so that means it's going to do this. So as x approaches negative infinity, f of x will be approaching negative infinity. And as x approaches positive infinity, f of x will be approaching positive infinity. Now to find your x-intercepts, a little bit more work. So I need to factor this. So I'm going to factor out an x, and then I'm left with x squared plus 3x plus 2. Then I have a t-chart situation. What multiplies to 2 and adds to 3, and that'd just be 1 times 2. So it'd be x, and then x plus 1, x plus 2. And so then I set each one of these equal to 0. So this is x equals 0, which is already done. X plus 1 equals 0, so that means x equals negative 1. And then x plus 2 equals 0, so that means x equals negative 2. And then for the y-intercept, so these are x-intercepts. For the y-intercept, I plug in 0 for all, so that's going to be 0 cubed plus 3 times 0 squared plus 2 times 0, which actually just equals 0, which makes sense if I have an x-intercept of 0. So when I graph this, I have a x and a y-intercept at the origin. And then additionally, I have a x-intercept at negative 1 and at negative 2. Since I know the behavior does this and finishes this way, I can assume we get something like this right here. Give or take. We'll learn how high this will go, but for now, that's about as far as you can go with it. All right, you're going to see problems like this one as well. So let's look at number 56. And so that's going to look like f of x equals x minus 1 times x plus 2 times 3 minus x. And again, you just be choosing the correct graph that goes with it. So determine your leading term. So that's x, negative x. So that right there would give me negative x cubed. So there's your leading term. Your leading coefficient is -1, and your leading degree would be 3. So that means I need to I start up and finish down. And so the only graphs on page 386 that only does that is we have B as an option, and B is my only option. So B is my answer. And that's really all I had to do. And I just had to look at the um, leading coefficients, leading term to determine, how does the graph start. Um, if I would have had multiples that were doing that, I would have then looked at my x-intercepts to go, all right, where were those random roundabout across? All right, so let's talk about inequalities. So let's look at number 67. This is going to be x squared is greater than x plus 6. And it says solve the following polynomial inequality. So we're going to solve this like a regular equation. So the first task I'm going to do is I'm going to set this equal to 0. So I'm going to move everything over. So I get x squared minus x minus 6 is greater than 0. I'll factor this like normal. So I'm multiplying to -6, adding to -1. So it's -3 and 2. So that gives me x minus 3, x plus 2. And this will give me x equals 3 and x equals -2. I went ahead and just solved them, but if you need to see it, this is what I did. All right, now these are not my answers. With an inequality, these are what I call my boundary numbers. So that's -2 and 3. Now you have to find test numbers. So find a test number that is less than -2. Don't go crazy. Choose something small. Something between -2 and 3 if 0 is ever an option. And then greater than 3. Don't go with 4. So then you take that and you have to plug it in to the equation. You can go to the original, but I'm just going to go here because my goal is it end up being a positive number, yes or no? So I got -3 times x, or if you want to plug it into this one, that's fine. -3 minus 3 would give me -6. And then -3 plus 2 would give me -1. Two negatives make a positive, so I know that part of the graph works. Now take 0. 0 minus 3 is -3. 0 plus 2 is 2. Well, a negative and a positive make a negative, which will be less than 0, so that part does not work. And you can work it completely out, but again, I'm just focusing, is it greater than a 0, yes or no? Now I plug in 4, so I get 4 minus 3, which is 1. 4 plus 2, which is 6. Two positives do make a positive, so that one works as well. So then your answer will be this part of the graph. So it's going to be -infinity all the way to your boundary number. And since it does not have a line underneath the inequality, it just gets a parentheses, union 3, because again, does not have a line underneath it, comma, infinity. So that's how you graph, or how you solve polynomial inequalities. So it's not as easy as just finding the x-intercepts. We got to find out on the graph, where is it above and below the x-axis. So let's look at number 70. 70 is x minus 2 times x plus 1 times x plus 3 is greater than or equal to 0. It's already kind of solved for us. So I get x equals 2, x equals -1, and x equals -3. Again, those are my test numbers. So I have -3, -1, and +2. Sorry, my boundary numbers. Now I need to choose test numbers. So I'm going to choose -4, -2, 0, and 3. As long as you choose a number between it, doesn't matter which one you choose. So now when I plug it in, -4 minus 2 is going to give me a -6. -4 plus 1 gives me a -3. And then -4 plus 3 gives me a -1. I'm looking for something that's greater than or equal to 0. Well, 3 negatives is going to make a negative, so that would not be greater than 0. So then I try -2. So -2 minus 2 gives me -4. -2 plus 1 gives me -1. -2 plus 3 gives me +1. Two negatives make a positive times a positive. I will get a positive result. Now I'm going to choose 0. 0 minus 2 is -2. 0 plus 1 is 1. And 0 plus 3 is 3. Two positives make a positive, but then one negative is going to make a negative, which will be less than 0. So then I try 3. 3 minus 2 is 1. 3 plus 1 is 4. 3 plus 3 is 6. Three positives make a positive, so that part of the graph will work. So therefore, my answer, because there is a line underneath the inequality, would be bracket -3, comma, -1, because that portion worked, union bracket 2, comma, all the way to infinity. All right, let's do another one. We'll look at number 76. That's going to be x squared, x plus 4, and x minus 3 is greater than 0. Again, it's already solved for you, so x squared would end up being x equals 0. This would be x equals -4, and this would be x equals 3. So I'd use my test point or boundary points. So -4, 0, 3. Choose my test point. So -5, -1, 1, and 4. Plug in -5. A -5 squared would give me a positive 25. -5 plus 4 is -1. And then -5 minus 3 is -8. Two negatives make a positive. Times a positive will give me a positive because I'm looking for greater than 0. -1 squared would be just 1. -1 plus 4 is 3. And then -1 minus 3 is -4. Well, that right there, two positive and negative, make a negative. So that'd be less than 0. 1 squared is 1. 1 plus 4 is 5. 1 minus 3 is -2. Again, two positive and negative make that a negative. Then choose 4. So that would give me 16 times 8 times 1. Three positives do give me a positive. So in this case, this is how my answer would look. -infinity to -4 with a parenthesis, so there's no line underneath it. Union 3 to infinity. There it goes. And there you go. All right, so you can get different kind of patterns and stuff like that. So don't get assumed if it's going to skip every other one or anything like that. And then of course it wouldn't be, college algebra if it didn't have some word problems. So let's look at number 78. 78 says a small startup skateboard company projects that the cost per month of manufacturing X skateboards would be C of X equals 10X plus 300. And the revenue per month from selling X skateboards will be R of X equals -X squared plus 50X. For what values of X will the company break even or make a profit? So in this case, I'm looking for profit. So my profit, remember, is revenue minus cost. And then from there, if I'm looking for break even or make a profit, that would be a greater than or equal to 0. So break even, I would, I'd make no money. And then make a profit, I'd be greater than 0. So now let's plug in our stuff. So this would be -X squared plus 50X minus 10X plus 300 is greater than or equal to 0. Distribute. So this gives you -X squared plus 50X minus 10X minus 300 is greater than or equal to 0. Combine like terms, so I get -X squared plus 40X minus 300 greater than or equal to 0. And then from here, I don't like dealing with negatives, so I'm going to multiply everything by a negative. And when I do that, all the signs change. But the golden rule with inequalities, anytime you multiply by a negative or divide by a negative, you must flip the inequality. So I'm going to look at it in this concept. So now I have to figure out, all right, well, what multiplies to 300 but adds to -40? And let's see. Okay, I got it. So 10 and 30, that'd be 300. And then two of them are negative. So then that'd give you -40. So this would be x minus 10, x minus 30. So that would give me x equals 10 and x equals 30 as test numbers. So here's 10, here's 30. Or my boundary numbers. So my test numbers would be 0, go with 20, and I'll go with 40. Kind of keep them kind of nice and easy. In this case, I'm going to look at this one here. So 0 minus 10 is negative 10. 0 minus 30 is negative 30. So that tells me two negatives make a positive, but a positive is not less than 0. So this would not work. 20 minus 10 is 10. 20 minus 30 is negative 10. So that would give me a negative, which is less than 0. So that would work. 40 minus 10 is 30. 40 minus 30 is 10. Two positives give me a positive, which is not less than 0. So that would not work. So that tells me as long as, what were we selling? Skateboards? As long as I sell between 10 and 30 skateboards, I will either make a profit or make greater than a break even if I'm at 10 or 30. All right, let's do one more, and that should give you plenty of examples. So let's look at number 83. 83 says an electronics company is deciding whether or not to begin producing phones. The company must determine if a profit can be made on the phones. The profit function is modeled by the equation P of x equal to x plus 0.27x squared minus 0.0015x cubed minus 300. Where x is the number of phones produced in hundreds, given this equation, how many phones must the company produce to make a profit? So this time I want to make a profit, so it has to be greater than 0. In this case, I'm personally probably going to use a calculator. I don't see any other way to do this by hand. Because you'll, I mean, let's see, if I pulled out an X 015. Yeah, no. So I'm going to plug this one to a calculator. So let me pull mine up real quick. And then hopefully when I switch over, it doesn't just delete or cancel this. But I'm going to graph this. And then I'm going to see, I was thinking maybe if I graphed factor by grouping, but I don't even think that would work. All right. So what I'm going to do is I'm going to screen share my calculator. And I'm going to go to graph and I'm going to type in that equation. So that was x plus 0.27 x squared minus 0.0015 x cubed minus 300. Now I can't see the graph, so let me zoom out. So I'll do menu, zoom out. All right, so that looks to be, anything else? It looks to be about right. So there ain't nothing. Oh, never mind. So we got a couple of things going on here. It is a cubic, so I'm thinking there's definitely gonna be two turning points. The goal was for it to be to produce, so it has to be greater than 0. So I'm looking at the graph to see when is it above 0, but we got to think of this realistically. So yes, the graph is above 0 from whatever this value is up, but we cannot sell, what is that, cell phones? Was it cell phones? Phones? Negative phones. So that means that I have to have a sell from here to here. What I gotta do is I gotta figure out what that number is. So to do that, I can do menu, trace, graph, and I'm curious what these values are. So I get 35. So I have to sell 35 phones. I did use the right equation, right? All right, so yeah, so menu, trace, graph trace. So I got 35, and I just kind of hit the right arrow key until I go to the tippy top, and I get 177.4. So here we go. So let me bounce back to where we were. So that's 35 and 177.4. So again, that was between 35 and 177.4. Let's see, but it says electronic sliding, blah, 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 the profit, blah, blah, where X is the number of phones produced in hundreds. So that's what it is. So got to watch out for that because this is the answer the graph gave us. But since X represents in hundreds, we just have to multiply both of these results by 100. So this will give me 3,500. And this right here, I'd move it twice. So this will give me 17,740. So as long as I sell between these two values, that's the answer your homework's going to look for. So watch out for that one. So, but again, on that one, definitely a calculated question. I have not quite taught y'all how to factor these out or what you can use. All right. But other than that, that is all I got for this one. So as always, if you got more questions, just keep emailing me. Other than that, I'll see you in the next video. Bye for now.